What's going on, guys? Let's look at this problem right here. Here this question is asking a 4 millicoulomb charge has velocity u is equal to 1.4 x minus 3.2 ay minus az meter per second at point p25 negative 3 in the presence of electric field that's given by this expression, and the magnetic field is given. Find the force on the charge at p. Okay, here the question is asking us to find out the force. Let's list all the given information. Here we have the charge, that's q is equal to 4 millicoulomb, and also we have the velocity u is equal to 1.4 ax minus 3.2 ay minus az, and then we have the point p 25 negative 3 in the presence of E, electric field that's given by this expression, that's 2xyz ax zax. This one should be ax and then x square z ay and then x square y az voltage per meter. This is our electric field, and then we have the magnetic field given, that is B is equal to y square ax plus z square ay plus x square az Weber per meter square. Okay, we have all this information, and the question here is asking us to find out the force. We can calculate the force using this formula. Force is equal to Q E plus U cross B. Now we have the general formula, and we have the 0.25 negative 3. This 2 is x value, 5 is y, negative 3 is z. So we can plug this one into the electric field and magnetic field expression and find out the electric field and magnetic field. Now let's calculate electric field first. Electric field is what? 2. Instead of x we plug 2, and instead of y we plug 5, and then instead of z we plug negative 3. We do the same thing for everything. Here x square is equal to 2 square, z is negative 3, and then a y direction, and then x square 2 square, y is 5, and that's it, az, and this is voltage per meter. Now if we multiply and simplify this one, that's going to give us this expression. E is equal to, let's simplify this one, 2 times 2 times 5 times negative 3. So 2 times 2, 4 times 5, 20 times negative 3, negative 60 ax plus, and here we have a negative, so 4 times negative 3, that's going to be minus. So this is going to become minus 12 ay, and then we have 2 square, 4 times 5, that's 20 az voltage per meter. This is our electric field. Now let's do the same thing for the magnetic field. We plug the points. Y square is what? 5 square ax plus z square, that is negative 3 square ay, and then x square is what? 2 square az. 5 square is 25 ax plus 9 ay plus 4 az. Now we have the electric field and magnetic field expression. Q is direct multiplication, E also direct addition and multiplication, but U cross B, if we calculate this one first, that's going to help us, like we can plug it in the equation directly, right? So let's go ahead and do the cross product. U is given here, and we are going to cross with B. The best way is to do the determinant method. So U cross B is equal to ijk x component, y component, z component. X component for u is 1.5, y is negative 3.2, and z is negative 1, and for b this is 25, and then 9, and then 4. Okay, like when we do the determinant, you can, like, we put plus minus plus, so the second term will be negative. And when we take I, we we eliminate all the xy component. And for 2 by 2, if you remember the 2 by 2 determinant method, ABC, if it's ABCD, we do AD minus BC. So we do the thing for everything. I hope you know that thing, or let's do it. Okay, so let's go ahead and do that. If I take I eliminate all the vertical and horizontal of this one. I eliminate this part, except I keep the I, but I eliminate all the vertical, horizontal along with that one. So this is the one that's left. So negative 3.2 times 4, that is AD. Like in this pattern you can say AD minus BC. So AD minus BC is what? 9 times negative 1, that's negative 9. So we do the same thing for everything. So, and if we simplify, I have the answer already. So you have to do the determinant for this one. And if you do the determinant and get the final answer, you are going to end up with this one. Negative 3.8 AX minus 30.6 AY plus 92.6 AZ. Okay, so this is our U cross P. Now we just have to plug it in this equation, and that's going to give us the final answer. So F is going to be equal to Q should be like this, Q, that is 4 millicoulomb, 4 times 10 to the power minus 3, and then multiply that one with E is negative 60 AX minus 12 AY plus 20 AZ. Okay, that is E. Then plus U cross B, that is this one, negative 3.8 AX minus 30.6 AY plus 92.6 AZ. So here we just have to add X component with X component, Y component with the Y component, and Z component with Z component, and multiply everything by 4 times 10 to the power minus 3. And after you do that, you will end up with this one. Instead of 10 to the power minus 3, we can replace that one with milli, because 10 to the power minus 3 is milli. We just have to multiply everything by 4, and after you add this XY component, XYZ component, and multiply by 4, you will get this one, negative 255.2 AX minus 74.4 AY plus 450.4 AZ millinewton, and that is the force. That is the force on the charge at point P. Okay, and that's how we do this kind of problems. I hope this helps. Thanks for watching.